Okay, 6D. 6D. The first one we got to do is number 15. 15 on 6D. I'm getting there. First question, 15 is basic skill concept. Subjective significance. 60 rolls of standard dice and you get 2 sixes. 2 sixes. What do you expect on 60 rolls? Well, you would expect to get 10 ones and 10 twos and 10 threes. You're rolling just one die. And so you expect to get 10 of each, and you got only 2 sixes. That seems a little bit off. Is that significant? Maybe. I mean, it could happen only twice, but boy, it seems like you should get closer to the 10. But it could happen. It sounds significant. Dice might not be quite fair. Okay, number 17. An airlines with a 95% on-time departure has 11 out of 200 late departures. 11 out of 200 is 5.5%. And they said a 95% on time, so 5% late is close to 95% on time, so this seems reasonable. No reason to reject what they say. 19. 10 winners in Powerball lottery in a row bought their tickets from the same 7-Eleven stores. 10 in a row from the same 7-Eleven, that seems unlikely. So that seems like this is more than just chance. Sounds like something's amiss. Okay? 25. 25, according margin of error. According to Gallup poll, 1,012 people, about 1/3, 32% of Americans keep dogs for protection. What is the margin of error at the 95% confidence level? Well, then that's 1 over the square root of how many they interviewed, which is 10, 12. So the margin of error, it'd be the square root of 1012, 1 divided by, got an extra one there. I got to take 1 divided by that, so I'm going to move back over here and go second insert 1 divided by the square root of that, and I get a margin of error about 3.1%. That's called the margin of error, and that's for that confidence interval. Then we're supposed to do 30, and 30 says there was 2,818 Americans in a survey, and that it's 73% of whatever, and 51% fall short. But all they asked us for, find the margin of error and the I have to do the confidence interval here, so I didn't do it on this last one. So I have to basically add 3% to that, so that'd be 35.1. And the lower end of my confidence interval would be 32 minus that, which is about 29%. So there's the confidence interval, there's the margin of error. So now I got to do it again for this one, and I got to do it for both percentages, 73% and the 51%. But they're going to have the same margin of error because they got the same number of people. So instead of 1020, 1012, It's 2818. 2818. And I get a margin of error of 0.19, which is about 2% if I round it. So it's plus or minus 2%. So that would fall, taking 2 off would be 71% to 75%. Taking 2 off of this would be 49% to 53%. And there's the confidence interval, there's the margin of error. Which I rounded to 2%. Okay. Next one is 33. State the null and the alternative and describe the 2 possible outcomes. So on 33, a college president claims that the 6-year graduation rate in her college is higher than the state average of 42. So we state the null is, it is 42, the same as the average. The alternative is, it is greater than 42%. That's what they're claiming. So now, what are the two, that's the null and the alternative, and what are the outcomes? That we either get enough information to reject the null, which tends to push us towards this, or we don't have enough information to reject it. So we're either going to reject or not reject. Reject and lean towards the alternative hypothesis. It doesn't prove it, it just says that we were able to reject it or we were not able to reject. That's 33. Let's go on to 36. Director of Public Works, same direction. So small town claims that the water usage in the household exceeds 1675. So we state it is 1675. Alternative, it exceeds 1675. Now, when we collect the data, we're either going to reject the null, if we've got something that's significantly different than this, than 1675, or we don't. If we reject it, we're assuming that if it's bigger, then we're going to go with the alternative, that it exceeds. So either we reject the null, or we don't reject null, which means we're probably tending towards the alternative, but we don't know, we haven't proved that it's the alternative, we just got information that rejects the null if it's not in the confidence interval. Okay, and that's 3638. CEO of an airline says that it claims the percentage of the flights are delayed are below the national average of 18%. So the null would be it is the national average of 18%, and it is below 18% would be the alternative. And so the two things we get are we don't have enough information to reject the null, so we can't say it's any different, or we get enough information to reject the null, so we reject the null and maybe lean towards the alternative, or we don't reject the null. That's the only outcomes you can get from an experiment. That's 38. Now 39. Car rental company says that they're below the national, or they're above the national average for number of miles used, and that is 11,725. So that's the null. It is 725 miles per car, and the alternative is more than 11,725 miles per car. And then it says in here that they got a getting the 12,000 is only, it happens with a probability of 0.01, which is 99% of the time they don't get that for all these cars, for a bunch of cars in the country. So if he got that, it's only one chance in 100 that that happens, which means that's better than the 95% confidence interval. So we would reject the null that it's this and say yes, it looks like they do have more than 1175. In fact, if it's only happens in 1% of the time that they got this, and that's only, it's only likely that you would get that 1% of the time, we can reject it at the 99% confidence level, or the 0.01 is there's a 1% chance that you get this, so we can say, oh, we can reject it at a 99% for sure rate, or a 1% confidence. 43, last one. 43, marketing company claims that homeowners in the population income of HDTV owners is more than 50,000. They took a sample of 1,700 households, and they got a mean of 51,182. Assuming that the true mean is 50,000, the probability of selecting a mean income is more, this or more is 0.007. That means there's 7 times in 1,000, less than a 1% chance. That's less than, this is less than, I better write it out. If it's less than 1% chance that you would get a mean greater than that, then, and you got that, then this must be significantly statistically significant, which means that yes, the mean must be greater than 50,000. You can reject the null that it is 50,000 because this is so much higher. It doesn't look like a lot higher, only 1,182, but it's so rare to get that much higher that you can say, well, it's more than 50,000. We can reject the null and lean towards this at a 99% confidence level, because this is even rarer than a 99%. Okay?